Hi, hello. Now I try to explain you this practicals. How the torsional motion of a disc depends on its mass and diameter. How the torsional motion. Torsional motion means this is the torsional motion likewise. If it's rotate likewise, okay, left and right, it is the torsional motions. Okay, the torsional motions of disc. This is the disc depends on its mass, how much it is mass and how much it is diameter, how it is depends to the torsional motions. That is, we will investigate this practicals. So next one, aim of this practicals. Aim. So what is this aim? To investigate the torsional motion of disc and how this motion depends on the dimensions of the disc. How this motions depends on the dimension of the disc. So dimension means it is mass and there is a diameter. It is there here dimension. So we will investigate this one. Then also this experiment using a stopwatch to measure interval of time, including the period of an oscillation system by timing an appropriate number of consecutive oscillations. So how much oscillation is there? That is, we want to note it. That is this practical aim. What are the material needed for this practicals? So one stand. So there is one stand is there here. So there is one stand. There is a stand. Next one boss. So this is the boss. This is the boss. So one clamp. There is one clamp. So this is the clamp. So this is the clamp. So this is the clamp. Okay, this is the clamp. So 100 gram mask hanger. 100 gram mask hanger. This is the 100 gram mask hanger, but here written 100 gram. Actually this weight is different, little different. So here next one 50 gram mask hanger. This is the 50 gram mask hanger. And 1 meter rule with millimeter scale. There is a 1 meter rule with millimeter scales. There is a millimeter means you know. So there's a 1 centimeter, there's a 10 line, it's a divide. 10 lines are divide. So there's a 10, that line is the millimeter. So one stopwatch reading 0.1 second or better. So this is stopwatch, it is read the 0.001. Okay. So next electronic balance. So weighing machines, we have weighing machines, and also 50 gram modeling clay. So modeling clay, just you take it. Now you see here, it is written 100 gram. So I will wait here. I put it weight here. Then it shows 91.07 gram. It is not exactly 100 gram. So okay. Now you see here the 50 gram. Okay, it is 50 gram is there, then we will check it. So this is the 51 gram. So if you want to measure anything, you don't believe this one. So you go and take how much weight is there. Then you take it, then you note it your note. Don't write directly how much here they are noted. Don't write directly that weight. Now you will know what are the materials, everything we have available. Now we will go for the practicals. So here the aim we know. So after that the theory. So diagram they are giving here. So diagram means why they are giving the diagram. From center this one we will rotate likewise. That is why the arrow mark here. That means it is rotational. It is be rotate likewise. Okay. So that is they give. So when a disc of mass m and radius r undergoes the torsional oscillation about vertical axis. This is the vertical axis. Okay, if it is hang likewise, it is a vertical axis. The period t is proportional to root of mr square. That means there is a time period. Time period of oscillation is the time period of oscillation is directly proportional to the root of mr square. Otherwise, t square equal to k mr square. T square means what? T square means time period of oscillation. T square equal to k mr square. K equal to constant. M equal to mass of the disk. M means this is the mass of the disk. R square means radius of the disk. How much it is radius? It is the diameter. Of diameter is the radius. Okay, from here to here, this distance how much? So radius of the disk. So mass, this is the mass of the disk, radius of the disk, r square. Okay, so that is, we will note it. So here t square, how much time period, is directly proportional to the mr square. Otherwise, t square equal to constant k mr squared. We can write likewise. So that is, we want to prove t square equal to k mr square, it comes or not. That is, we will prove here. This theory is beyond AS level, but relationship like this can be used for as AS investigations. So it is beyond the AS level, but you can investigate how much it is the torsional motion, how it is depends, everything you investigate. That is why they give. During these investigations, learner will suspended a mass hanger of mass m and radius r and noted the time period t, the rotational oscillations. They will do this for two mass hanger of different mass and different diameters. So different mass and different diameter. So there is a 91 gram mass, there is a 50 gram mass. So the both is a diameter also different. It is big size diameter, there is a small size diameter. So we will take likewise, diameter not same both. Okay, the different diameter and different weight you will take it. So the relationship between a time period, mass, r, we will see now. What is the relationship between a time period, mass and radius? Since two results are insufficient to draw a graph, so there is a two result. The two results are insufficient. That means 50 and 100 gram. If you take this two reading, that is not insufficient to draw graph. You may wish to encourage to learner plan and carry out further experiment using the modeling clay. Use modeling clay. At the time mass will be increased. Use modeling clay. You paste it here. At the time 100 means if you paste modeling clay, weight is increased. And also you paste modeling clay this round. That time the diameter also increased. At the time it is, you can get it the some value. So it is useful for do a graph. Now method for both 50 gram and 100 gram mass hanger, learner measure the mass m and radius r, the widest point. So now we will measure, already we measured mass, we will measure now radius. So how do we measure the radius? So we will put likewise, then how much radius is there. Okay, then we will find it likewise. So this is the 100 gram. So 100 gram, how much radius is there? Exactly, it is a 3.6 centimeter. So M1 is the 91 gram, and already I measured this one. R is a 3.6 centimeter radius, and M2, this is the 51 gram 51.18 gram, that I consider the 51 gram. So it is a 3 centimeter. This diameter is I measured through the scale, I get it 3 centimeter. Then M1 I convert into the kilogram. This is the gram, it is I convert into the kilogram. Suppose if I want to convert this gram to kilogram means, so low value to high value. So we divide by 1000. Okay. So if you are divide by 1000, we will get it 0.091 kilogram. And M2 51 gram. If I want to convert into the kilogram means divide by 1000. So I get it 0.051 kilogram. Then this is the 3.6 centimeter. The centimeter, if I want to convert into the meter means we divide by 100. Okay. So if you divide by 100, we will get it 0.036 meter. So there is a 3 centimeter. M2, that's a 50 gram. So 3 centimeter, if you are divide by 100, you can get it 0.03 meter. So you do this part. Then afterwards we come to the tables. So here mass by kilogram. So mass, how much is the mass? There is the 0.091 kilogram. Here also 1 kilogram they are giving here. So that kilogram I write here. Then kilogram it is cancelled. Remaining 0.091. Here 0.091 only I written here. That is why they are giving here kilogram. That is why they are giving here meter. Here that is why they are giving meter square. Meter square it is be cancelled. Okay. So 0.091 kilogram and radius. So radius is 0.036 radius. This is the 91 mass. So radius square means we multiply by 0.036 into 0.036. If you are multiply, we will get it 0.001296. So now time period. How do we take time period? Time period of oscillations. First I will take this one. So first you take it this one, a rubber band. There is the rubber band. Hang the rubber band and hang into the 100 gram mass. So here learner to investigate the validity of relations T square equal to Km r square. K is the constant. So you do like that setup. Now I started to take reading. So you keep it safe likewise. It is okay. Now you rotate likewise. Then slowly you move. How is which one is the one oscillations? It is here now. It is come back again. This is the one oscillations. Again it is come back. This is the two oscillations. Again it come back here. 3 oscillations. In this way you take oscillations. Now 10 oscillations I will take the readings. This is the stopwatch. Now I on here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 oscillation I get it 0.25. So here I write 34 seconds. So before I take reading, that time I get it 34 seconds. That is I write. After that 25 seconds. So here after that I take T2. The similar way I get it 27. That is I write. So both if you take average means 34 plus 27. We add and we will divide by 2. Then we will get average. That average is, it is comes nearly Um, okay, you take average and divide by 2, then you get it to an answer. Okay, that answer T average. Okay, what is now? You see here 34 plus 27. 34 plus 27 is 61. Is 61, if you divide by 2, we will get it 30.5. We will get it 30.5. 30.5 we divide by 10. Why we are divide by 10? Here time period. So time period equal to T average by number of cycle. T average. T average means 30.5 and number of cycle. Here time for 10 cycle. Okay, so that is why time for 10 cycle. So here I write 10. So 10 divided by 30.4, it comes 3.05. That is why I write here 3.05. T square. T square means 3.05 into 3.05. We get it 9.3025. So after that we will find it K equal to, so here their unit only they are giving K divided by second square. Second square means what? Time. Time unit second square. And mass. Mass means kilogram. Okay? Kilogram. So because it is comes up, if mass goes up, kilogram minus 1 we can write like this. Radius. If radius goes up, the unit is meter minus 2. We will write likewise. If it is by means, we will write in plus. If it goes above, we will write minus meter minus 2. Likewise, we can write likewise. Okay. So they are giving unit. So the unit means this is the concept. Constant equal to T square by mr square. So T square, how much it is they are giving here? T square is 9.3. 9.3025 they are giving here. So and mass, how much mass is there? 0.091 and radius square. Radius square is 0.09 0.001296. So here 0.001296. Okay. Then you multiply here. If you are multiply, we will get it this answer. So here 9.3025. Though you can divide 9.025, this you can divide. You can get it 78,000. No, 78,85,632. This is the K. So what is the afterwards? K mr square. Suppose this constant, you see this formula, when it is mr square, it comes here. K mr square equal to T square. That is we want to find it. So this is the our concept. T square equal to K mr square. It is becomes equal or not. That is we want to check. So if you are cross multiply the K mr square. So K value this one. So mr square value already we are find it here. Mr square value. That is we will write here. Both if you are multiply, we will get 9.30. We will get 9.30. And already the T square we know here. T square already we find it here. T square 9.30. So both it is comes equally. So hence it is proved. The similar way you can do next one. Already I did. So 51. There's a 51 gram. I convert into the kilogram. 0.051 kilogram. There is the 3 centimeter. I convert into the meter. At the time I get it 0.03. The similar way I will take it. It is also comes here. The kmr square. Then I substituting here. This also it is comes same T square value and also kmr square value. Both it is comes same. You do likewise, then you can get it the proper answer. Now we finished the investigation of torsional motion of disc. How the motion depends on the dimension. So the T square equal to this is the T square equal to K mr square. That is we finished. Okay, now we will see this one. So we will see this one. So there is a second experiment, so practical to the worksheet. To use stopwatch, measure the interval of time, including the time period, oscillations, so everything you want to measure. So the similar way, the same procedure, determine the 100-gram mass, widest point or radius, estimate the percentage of uncertainty. So percentage of uncertainty, that means what? So uncertainty is a total time taken. So total time taken means how much is the total time taken here? So 24, if it is take this one, suppose if I take 34 seconds. So total time taken is the 34 by the least count. The least count means what? How much time we can measure this one? The lowest time. This is the lowest time. That is the least count. Okay. The lowest time is the 0.01. 0.01. That is the lowest time. That is the least count by total time. So total time is 34. So 34 0. If you divide likewise, we can get it some. We divide and multiply with 100. Okay, in this way we will find it the uncertainty. So here time is least count. There's a mass means 1 gram. That's the least count. You will take radius means how much it is comes. This is 3 centimeter means 1 millimeter scale we are using. So 1 millimeter. That is the least count. We will likewise we will use then 1 millimeter means 0.1 centimeter by the total centimeter is the 3 centimeter. So 3 centimeter into 100. So this much percentage. Likewise you can find it uncertainty value. So percentage of uncertainty, that means you will find it how much error is there. In this way you find it. So first thing, uncertainty is equal to least count. Which least count, which material we are taking, if you are using this watch means this watch least count, how much total time I am taking this one reading. Okay, that is you do, then you calculate, then how much error you find it. Okay, in this way you find to uncertainty of error. And also here also same procedure, you do the twist the mask hanger through the about the half turns. Half turn means now you see there is a full turns is there. Here it is see in this way it is here. There is a 0. Half turn means it is comes here. This is the half turns. Then 1, 2. In this way you take reading. Then you fill this the similar way. The same, both reading is same. You see mass here, radius, r square, t1, t2, t square. That's the same they are giving. The how I teach you before, the same way you do this one. Okay. After that they are giving here interpretations. What you are learned, that is you write here. So now I hope you understand little much. If any doubt, if anything is there, you put comment. Thank you.